Hello everyone, I'm excited to present you my new project called ECRO, Employee Commute Route Optimizer. Here's a little presentation on how everything works. I'll try to go through it. So let's answer the following questions first. What is ECRO? What can we expect from ECRO? What are the benefits of ECRO? Where it can be used, the architecture of ECRO with Apache Kafka, and why ECRO uses Apache Kafka. So what's ECRO? ECRO, it's a short term for Employee Commute Route Optimizer. It's a project designed to optimize employee commute routes. It leverages Golang channels, Docker, Kubernetes, and APIs to find the most efficient routes for employees traveling between their homes and workplaces. So it's a routing application, routing software, open source software that can help to find the shortest path from your current location to one of your work offices. So what can we expect from ECRO? With ECRO, we can expect significant improvements in employee commute efficiency. It aims to reduce travel time, minimize congestion, and enhance overall workforce productivity. By providing optimized routes, ECRO helps employees reach their destinations faster and with less stress, also with the smaller price. So what are the benefits of ECRO? Reduce commute time. Employees can save valuable time by taking optimized routes, leading to increased productivity, improved employee satisfaction. Shorter commute times and less congestion contribute to a more pleasant work experience, leading to higher employee satisfaction and retention. So where it can be used? ECRO can be used in various industries and organizations where employee commuting is a significant aspect, such as corporate workplaces, educational institutions, healthcare facilities, logistics and delivery services, and many more. You can integrate actually ECRO in any aspect of your life. The architecture of ECRO was Apache Kafka. So here I'll be trying to answer why I use Apache Kafka with ECRO. So ECRO utilizes the Apache Kafka messaging system as part of its architecture. Kafka acts as a high throughput distributed messaging queue that facilitates communication between different components of the ECRO system. It enables real-time data ingestion, processing, and exchange between the ECRO consumer and producer components. So mainly the ECRO project, it wasn't implemented with Apache Kafka. So it worked the following way. So you sent a request to the software, and it forwarded your request directly to foreign APIs, got the results, the responses, and forwarded them back to the client. So incorporating Kafka actually helps to increase productivity of the software in general, the throughput, and actually consistency. So here is the solution architecture for the ECRO. As you can see, so there are like several components: ECRO producer, ECRO rec topic. This is the Kafka topic running in a cluster. Consumer group, also consumer, and ECRO REST topic. So how it works? It works the following way. So producer is actually the system that actually user sends his request to. So user sends its request to producers, to ECRO producer, that is deployed in Kubernetes as pods and managed by load balancer. So the producer sends the request to ECRO rec topic, and this request actually contains like data such as your current location, current geolocation, and the destination locations. They can be at least one, two, three, whatever. So the request is received by ECRO rec topic, At the same time, there is another service called ECRO consumer, also in pods, that's listening the current ECRO rec topic for incoming messages. So every message produced by the producer contains a unique ID that consumer actually consumes from message. So consumer gets the message, the incoming message, with the ID assigned by the producer, forwards it to foreign APIs to get the routes. It can be any API, Here API, Google API, OpenStreetMap API. The current implementation, the current version I used Here API, but it can be several, it can be many. So after the response is received, consumer produces actually this message to ECRO REST topic, to ECRO response topic, with the ID assigned by the producer. And at the same time, the producer also consumes the messages from ECRO REST topic and waiting for the response that contains actually the ID that it's generated for the request sent to the ECRO rec topic. So once the message with the awaiting ID is received, the message is returned back to the producer, and producer returns it back to the client. So why ECRO uses Apache Kafka? Why not other systems? Scalability. Kafka is highly scalable, allowing ECRO to handle large volumes of route requests and responses efficiently. Fault tolerant. Kafka's distributed architecture ensures data reliability and fault tolerance, making it suitable for critical applications like ECRO. Real-time data processing. Kafka enables real-time data ingestion and processing, ensuring timely delivery of optimized routes to employees. Employees or any other user. Data integration. Kafka seamlessly integrates with various data sources, enabling ECRO to incorporate real-time traffic data, employee locations, and other relevant information into the optimization process. As I said, so currently this data source can be considered as Here API and the data that it uses, but in the further updates, more flexible mechanism will be implemented, so that not only Here API but any kind of API can be integrated. So actually, apart from the main goal of ECRO, the whole solution architecture can be actually used in many other purposes. Not only finding the route. So you basically can clone the Git repo and start experimenting with it. Implement any kind of service. So the main idea is the message forwarding between services, between microservices. So I'll show you the repos. So here is my repository. I'll share it with you. So there are 3 repos of employee commute route optimizer. So this is the first one that actually didn't contain Kafka in it. So employee commute route optimizer is written in Golang, leveraging channels. And here you can actually find the architecture of the project, the package diagram, the class diagram. Also, you can go to CRC folder and find actually the packages that are used in the process. And these are the 2 actually services that are meant to run in Kubernetes. So currently they work, but currently they have their Docker files integrated in them, but not Kubernetes. So I'll implement Kubernetes part of the architecture, so this part in the later versions of the project. But currently it works with the Docker. So I'll also share the links with the following repos. So consumer is this one, the one that runs in the consumer group of Kafka. You can actually Just open it and go through it. All the guidelines on how to use it are described here in the readme.md file. So the CRC also we have like packages. We have packages, producer, response, route finder, the structure that actually parses the responses. All this will be fairly simplified in the further updates. So yeah, so this one is optimizer producer. That is this one, the service that's on the upfront, the front line of the whole process. So also the guidelines are all in here, how to install, how to configure. So basically what you'll need to do, you'll need to create config.json file. Config.json file, I'll try to show it to you. The producer. So config.json file here, and put your API keys in it. So you'll need, for this implementation, you'll need here API key and Google Map keys. So yeah, and then after actually putting your stuff, your configuration properties in it, you'll need to run the application using the start command, or you can run actual Docker container. Replace the placeholder value with your here API key. So yeah, so config, so it's in config. We can go here. There's a package called config module, not config. I'll just fix it. Config module.go. So here you see, so you specify port, Google Map API key, here API key. So all these keys have to be written in the config.json file, so that after you call, the config.json can, parse all of them into the config module. It's fairly actually easy to get these API keys. You can just, open the website, and there are all the guidelines and tips on how to do it. Just fairly easy. Here API, geocoding API. Yeah, you can just enter here API, here.com, register, and generate your API key. And you'll have to tweak around the permissions as far as I remember. So make sure that all the permissions for your API are turned on, so that when you make requests to the service, everything just runs smoothly. Yeah, so as I said, these repos contain Docker files. You can actually deploy your Docker containers and run the services from Docker containers. Both of them have. In the further updates, I'll add the Kubernetes part to implement, the whole solution architecture. But this was a simple introductory video to ECRO and how to use it, and what it is, and what is solution architecture, how it works in general, what is it used for, and so on and so forth. So thank you for your attention. I hope you'll find this project useful for many purposes. And if you have any questions, I'll drop my Gmail address here, so you can easily get in touch with me and ask questions. Thank you for your attention.